Hi guys. Okay, so now let's talk about accuracy and precision. First thing I want you to know is that, like in casual English, the terms accuracy and precision are used interchangeably, but in a scientific context, they mean different things. Accuracy is how close a measurement is to a known value. So like if we know that the density of water is 1.0 grams per milliliter, and then I go and I do measurements, and from those measurements I calculate that the density of water is 1.1 grams per milliliter, that was a fairly accurate calculation. I was relatively close to the known value. Now with precision more focuses on the instrument itself. So let's think of a scale. Let's say I take the same 500-gram weight and I put it on a scale over and over and over again, and the first time the scale reads 500 grams, and then the second time the scale reads 250 grams, and then the third time it reads 650 grams. That is not very precise because those measurements of the same mass were not very close together. So it wasn't a precise scale. Okay, so we can represent this idea through the concept or the thought of playing darts. So here you can see that what we're going after when we're playing darts, that desired or known data point, is the bullseye. And so here we have a dart right in the middle, so that was an accurate data point. Now over here you can see that these data points or darts are not close to the bullseye or the known value, but they are all very close together. The instrument's giving them the same number almost every single time. So it's precise, but it's not accurate. Okay? Think of it back to our example with the scale. Let's say I have a scale and I put a 500-gram weight on it, so we know it's supposed to be 500 grams, and it reads 201, and then the next time it reads 202, and then it reads 200 the third time. That was very precise. Those numbers were all very close together. We were getting relatively the same data each time, but it was not very accurate. It should have been reading, if it was accurate, close to the 500 grams. Now here we have precision and accuracy. Now the scale's reading 501, 500, 502, okay? And then the last is it's not precise and it's not accurate. Okay, the next thing we talked about was known and estimated digits. Okay, so let's think through this in terms of the precision of an instrument. Okay, so as humans, we can only make an accurate estimate to a tenth between calibration marks. So if I have a ruler, and in this ruler, we'll say the ruler, started all the way back over there at 0. And this is 4 centimeters, and that's going to be 5 centimeters, and then here we have 6 centimeters. Okay, and my object started back at 0, and now it's ending right there. Well, how long? What is the measurement of this object? Well, I am certain that it's past 4, and I know it's not to 5, so I have 4 centimeters. Now I'm going to estimate between these calibration marks, and I estimate that it's 7/10 of the way to the next calibration mark, so that would be 0.7 centimeters. This value I was certain of, and then this one was my estimation. Every single measurement we make will have only one estimated digit, but it could have multiple certain digits. Alright, let's look at these rulers now, and we have our object, and we'll say that they are also centimeter rulers. And so we are certain for ruler A and ruler B, we are certain that we are past 11. And now we have to make an estimation in between. Another thing that might be really helpful is kind of analyzing the tool that you're working with. So when I look at this, my calibration marks are all whole numbers. Okay, so my whole number values, I'm going to always be certain of those with this instrument. And so they're my smallest calibration marks. So when I make a measurement to a tenth in between there, our tenths place is always going to be the estimated one. Now when I come and I look here, I see that there are calibration marks to the tenths. So my whole numbers, I am certain of those, and I'm also certain of the tenths because I have calibration marks within the tenths. But notice that the tenths is the smallest calibration mark, so my estimation is going to be in between those. So my estimated digits is in the 100ths here. Okay, so here I'm certain I'm past 11, and then I'm going to estimate that I am at, let's say, 11.6 centimeters. Okay, now I'm going to come down here. Okay, I'm certain I'm past 11, I'm certain I'm past 11.5, I'm certain that I'm past 11.6, but just barely. So that would be 11.6, and I'm estimating that I'm 1/10 of the way to the next calibration mark. Now, what if my estimation was that I was right on that line? So let's say that I didn't think it was just past it. I thought it was right on the line at 11.6. Now, this is where my students get the most confused with this. According to this tool, the 100ths place here is going to be the estimated value. So I do need to give an estimation, but I feel like it's right on that calibration mark. So my estimation is that I am 0/10 of the way to the next calibration mark. Okay, so you look at your tool, you say, okay, there are 10 calibration marks in between my whole numbers. So I'm certain of my whole numbers. I am certain of the tenths because I have calibration marks that represent those. And so I'm estimating in between those calibration marks. All right, now this is not always just for rulers. It's pretty much any measurement that we make. So we will also be doing this with graduated cylinders. First most common error that you see with rulers, but definitely when we're measuring volumes, is parallax error. If you need to, when you make these measurements, need to be directly eye level. If you look up above, then you're going to read it incorrectly, or if you look below, you're going to read it incorrectly. Okay. The second thing is make sure with volumes that you're reading from the bottom of the meniscus. And a meniscus is kind of that curved shape that the liquid makes within a graduated cylinder. Okay, so I say that the bottom of my meniscus is right there. Okay. Let's see what our estimated value would be with this. So we have whole numbers, so we have 50 and we have 60, and this represents 51, 2, 3, 4, 5, 6, 7, 8, 9, 10. So those calibration marks represent the whole numbers. There are no calibration marks in the tenths, so that is my estimated. So when I look at this, I say, okay, I'm certain that I'm past 50 and 51 and 52. Okay, so those are my whole numbers. And now I estimate that I'm 8/10 of the way to my next calibration mark. So my final answer would be 52.8, and this graduated cylinder would say it's measuring in milliliters. Okay, Again, for temperature, first look at your device and decide where the estimated value is going to be. So I see 80 and I see 90, and we have 10 calibration marks, and so it's counting each calibration mark is a whole number. So I'm going to be certain of those whole numbers, but then I'm going to be estimating the tenths value there. And so I'm certain that I'm past 85 and 86 and 87, and then I'm estimating that I'm 6/10 of the way to the next 88th calibration mark. Okay, the last tool where you're going to be making measurements is a triple beam balance. Take a moment, make sure you've read through those rules, but let's focus on those certain digits and your estimated, okay? Because it can get a little confusing when we're looking at 3 different bars here. So the way that a triple beam balance works is we put all of these weights at 0. And we start by moving the 100-gram one first. And then once it tips the scale, then we put it back to the one before. Then we go to the tenths, and we start moving that until it tips the scale, and then we go back to the one before. And then our last one is a sliding one here. And so it starts at 0, and we slowly slide it until we're all balanced out there. Okay? So when I read this, I say, okay, I have 347. Okay, now notice first we have 7 and 8, and so our certain digits are also in the tenths. Okay, so we have our whole numbers we're certain of, and we are certain of the tenths, so our estimated is in the thousandths here. So I am certain that I am at 7, and I feel like that when I see that, it's right on that line, and so I am certain that I'm at 0.0, and I'm estimating that from that line that I am 1/10 of the way to the next calibration mark. All right, guys. Let me know if you have any questions at all. Feel free to email me or come see me in class or sign up for a study session. Okay?